All right.
It's Coach Jay, pre-cal review. How are you doing today? Hope you're doing well as we prepare for the test. Right now we're at 7:10. Well, really, it's actually 7:25 on a Tuesday. And I'm not going to sing the song, so we'll just go with it. But we are really excited to be here. Hopefully this helps you prepare for the pre-cal test. And just because I can and because I'm so excited, look what the God Ants, Riley and Dynasty got. Isn't that the cutest thing? Look at that.
Yeah.
Look at that right there.
Emmy.
Little Emmy right there. Anyway, I'm psyched. Hopefully you're psyched. I'm psyched because I'm having a child. I'm also psyched because we're doing some math. So let's get it rolling. And I'll get this thing underway. Perfect. All right. So let's do this. As we do this here right now, I'm actually live right now. First time we've actually done one this year where I have people with me. Right now, currently, we got
even a part of Precalculus.
I know. I've got Algebra 3 students in here too. But I've got Jalen in here right now. I've got Rachel in here right now with pre-cal. And I've got Blair from Algebra 3. And so we're going to learn some math here. So we're going to ask some questions. And so as we go through, if we've got questions, it'll come strictly from people in this class. And hopefully it helps you there. Okay? All right? Awesome. Let's get it underway. Y'all have a good first question at all as you look at the review? Rachel and Jalen?
All right. Let's see.
I was going to ask about number 8.
Number 8. Jalen's got number 8 there. I like number 8. I haven't even looked at number 8, but now I did. See y'all. Thank you again. On number 8, one thing to really note is that what we want to make sure we set this up to where we solve for one of the values. Now, one thing that's a little bit different is that some things are squared. For instance, when I have x squared plus 2y minus 5 equals 0, let's see, Blair. And then the second one is 3x squared minus y minus 1 equals 0. What we can do is isolate by either substitution or we could use elimination. Does not matter, okay? Now, one thing I note is that at the top, there's a 2y right here at the top, and down below there's only a negative y. So what I could do is multiply both of these, or the bottom one by 2, right? Because if so, then I could cancel. So if I multiply this bottom one by 2, again, this is number 8, what I'll end up getting is 6x squared minus 2y minus 2 equals 0. And so this would no longer be there because now I've got it simplified. Well, again, 2y and negative 2y are now gone. So where now I've got 7x squared minus 7 equals 0 because I combine whole numbers and x squared is there. Okay? So once I do that, what do I do to isolate x squared or x? Add 7 and divide by? Perfect. Yeah, Jalen's right. So we're going to add 7 and then divide by 7. So I have 7 over 7 equals x squared. So now since I've got that, I've got x squared equals 1. So we're now if we square root both sides, x equals plus or minus 1. Remember, if I square root a squared, I could have a plus or a minus, okay? Now, one thing to note is this. A lot of times what we'd like to do is be able to solve for what is x squared first, because we can get multiple values. Then we could plug 1 and negative 1 back in to find out what y is. Does that make sense? So let's find, again, we'd like to isolate the x squared just like we did here, and then we could plug 1 and negative 1 back in to be able to find out what that x is there. What's up, Kennedy? Kennedy's with us on the podcast, so we're going to get questions from her as well. So again, what we're going to do now is plug it back in, 1 and negative 1, back in for x. So what we have is this. 1 squared plus 2 times y minus 5 equals 0. So we have now 1 plus 2y minus 5 equals 0 there. What we can do is say 1 minus 5 is actually negative 4. So we got 2y minus 4 equals 0. Add 4 divided by 2, y will then be equal to 2 there. And again, that's if I plugged in 1, right? Now, here's the thing. If I plugged in negative 1, would anything change? No. Exactly. Since I'm squaring it, we'll stay positive. So the only value that I could get out for y would be 2. We have our answer should be x is equal to plus or minus 1 and y is equal to 2. Another way you could write it is this: 1, comma 2 and negative 1, comma 2, right? And so for both of those are 2 possible values that you could have to be able to answer it sufficiently. You could put it either way. All right? Does that make sense?
Yeah.
Awesome.
I have a question
Go, Rachel.
about elimination.
Mhm.
So that was substitution.
Now that was actually elimination, where we just eliminate. We multiply by something common. Awesome. Thank you.
Multiply by something in common.
Yeah, like the 2, right? We
Okay.
multiplied by 2.
Yeah.
Once I multiplied by 2, I could get rid of that 2y and negative 2y, right?
Okay. Yeah.
And so once I've done that,
Oh, now I'm following.
now I can eliminate, right?
Yeah, gotcha.
Now, when we do systems of 3 equations, right, we could do one of those. One thing that I always continually tell you, isolate one of the equations, substitute in for the other 2. That's substitution. Like where x equals 2y minus 5, I take 2y minus 5 and plug it in wherever I see x. So that's the difference there when we're solving on that side, all right? Sound good? All right, perfect. Again, we're on a podcast live here with Precal 12. We're on number 8 we just solved. Is there another one as people or individuals in the room? Is there another one that we could go over that you see off of the review? Okay, off of the review.
Number 6 and 7.
All right, let's look at number 6 and 7 there. Yeah, let's look at number 6 on that one. All right. Oh, those are good ones. All right, number 6 is one where we're really going to try to make sure that we've got to analyze what's going on with the problem. As far as number 7 is concerned, remember, number 7 is pretty easy in the sense that you just need to know how we find the solution to supply and demand, right? Well, if I've got a supply equation and a demand equation on number 7, we can solve for what the x and y is by setting them equal to each other and solving, all right? Does that make sense there? So on number 7, you actually don't have to put them in an equation. They've given you the equations to find where we call it the point of equilibrium. We just solve what the x is by substituting in, setting them both equal to each other, solving for the x, and then evaluating on the y. Does that make sense?
Yeah.
All right. Number 6 is a good one, like Rachel said. That one's one that's kind of a word problem that had tripped us up in the past. This one says, suppose you're setting up a small business and have invested $5,000 into the business, right? So this is the pay that's going in to the business, right? Right? That's what's going in. So it's going like that's what I have to pay in order to have the business run. It also says to produce an item that will sell for $9, okay? All right, so literally what we're doing is what's going back to me, right? So this is me. This is the business. What's coming back to me is $9 per item. Does that make sense?
Yeah.
So that's what's coming back. But each unit can be produced for $7. So in order to sell it for $9, I have to buy it for $7, right?
Yeah.
So really, this is 7x2 that's going into it, right? So 7x and $5,000 is going into the business. What's coming back to me is 9x or $9, okay? So in order to come up with this equation, it says how many units must we sell in order to break even? Does that make sense? So what I've got is I've got money going in, and then I've got money coming back to me. So when I look at it, what could I do to come up with both of these equations?
Set 5,000 equal to 7x?
Not quite. Let's do this. Let's come up with 2 equations. Close though, Rachel. Let's come up with a cost equation and a revenue equation. So how much? Yeah. Perfect. Nice, Jalen. 5,000 plus 7x is what cost me, right? Okay. What's my revenue? 9x. Very good. Perfect. We can now. You might say, well, these aren't equal to each other. I get that. But if we're trying to find how many of x we need to sell in order to break even, just set them equal and let's solve. So let's say 9x equals 5,000 plus 7x. So we could subtract 7x on both sides to get 2x equals 5,000. right? So what would X be equal to? How many items must I buy in order for, or how many items must I sell, rather, in order to break even? Nice. Good, Jalen. 2,500, and that's literally all I would do for that problem in evaluating that, all right? It's not too bad, right? I think, does this help y'all right here? Hopefully that helps y'all at home. Does that help y'all? Like what's going to the business, what's coming back to me? Draw pictures because sometimes that does help going forward. And so if you could kind of picture that, it may help you on that one, all right? That make sense?
Yeah.
Number 7, does that make sense once I've talked through that? Supply and demand, setting them both equal to each other and solving?
Yeah.
Does that make sense? So again, remember, just to give you a picture back at home, and those that are here, I appreciate you for being here. The fact that you're here will reward each of you 2 points on the test. Great job.
Oh, thank you.
Yep, great job. So first off, I've got y equals 220, or p equals, but you get the idea, of minus 0.0002x, something like that. And then same idea down here, it's y equals, or p equals 90 plus 0.0003x. Again, if this is my demand and this is my supply, the point of equilibrium is where they intersect, right?
Right.
So literally what you could do is when we talked about substitution, set the bottom, plug it in for the top, and so we've got 90 plus 0.0003x
So
equals.
you're quite literally making them equal to each other.
That's it.
You're not like, okay, cool.
Does that make sense?
Yeah.
You could eliminate, but it's going to be a lot tougher.
Gotcha.
Okay? I would just set them equal to each other. Solve for x. I think it talks about find the point of equilibrium. That means x, just tell me the amount of units, which is x, and then p or y would be the amount of dollars created. And again, that tells me how many units I could sell at so many dollars. And that's the point of equilibrium. A lot of times when, like I'm drinking Starbucks right now, the point of equilibrium is where the cost and the demand end up intersecting to where it kind of gives us what, how much they should sell that for. And it should, and again, it's a little more complicated than that, but that's the idea in a simple format with what we're doing.
Cool.
All right? Sound good?
Yep.
Also, I know Kennedy, as you come in, I know I'm going to answer questions more on the homeworks later today, but I don't know if you see any problems on the homework that correlate to the review that we could do on here. But if you do, I'd love to throw those on there and kind of go from there. All right? And while I'm doing that, if we could at home, let's pause for just a second. You could pause this or skip forward. I'm going to be right with you. I'm just going to get a test for a student, and we'll go through one of the problems here shortly. I'll get those for y'all. Yeah. Is it a test? Quiz, right?
Test 5.
Say that one more time. I'm sorry.
Test 5.
Test 5.
Yes.
And with the supply and demand, then you just solve, right?
Correct.
Solve, right?
That's exactly right.
Johnson, do you happen to have a formula sheet?
I don't on me. What time did you get here? 7:30?
Yes.
7:30? I don't think we would have been able to take it anyway, because in 30 minutes, that wasn't enough time for us to take it. You know what I mean?
Yes.
So could we do that? Could we do this tomorrow morning? Let's get here at like 7:05, 7:10,
Okay.
and that way we can do it. Because 30 minutes, because that means we would have to break it up and just trying to be fair in that. So if we could do that, and then I have formula sheets and everything. We can get one for you. Okay. But let's get that there tomorrow. And let's get that done tomorrow. Sound good?
Yes, sir.
Thank you very much. All right, coming back live for you. Sorry about that. Wanted to touch base with you on a couple other questions. Kendi? 15 is a good one. Let's look at it. All right. On number 15, we have x minus y plus z equals 6. And then the second one is 2x. Thank you very much. 2x minus z equals 4. All right. And then the last one, negative x minus y minus z equals negative 4. All right. Now, here's the deal. Okay. A lot of people struggle on these. Now, I'll tell you that if you've watched the podcast, I did it a completely different way. But as I've thought through it, the easiest way is this. The easiest way, isolate one of the equations and set it equal to the other two. All right? If you do that, you'll get it every single time. Well, as you look at this, which one probably would be the easiest to isolate? Second one, right? Because it's got the least amount of stuff. So if we do that, we could subtract 2x. So I'm going to subtract 2x to get 4 minus 2x equals negative z, okay? Equals negative z. So once I do that, I'm going to change the sign of this z, which will change 4 and change that 2x, all right? All right, so far so good? All right, so now we've got z equals negative 4 plus 2x. Is there anyone confused on that right now? Or are we okay? Jalen, you good over there? Yeah, all I did, subtract 2x. Say again? Yeah, this is literally, this right here is all in the second equation, okay? So I'm going to plug that in for this bottom one and the top one. So now on the top, I'll have x minus y plus negative 4 plus 2x, that's the top, equals 6. And on the bottom, I'll have negative x minus y minus, and then put negative 4 plus 2x in, and then equals negative 4, okay? So again, this is number 1, where this is number 3. All right, does that make sense so far? When you do that, here's what happens. Now I've got two equations with two variables. We solve it the exact same way we've done it in the past and on the previous ones. When I checked out the test, I think it was this morning or yesterday when I was kind of putting my final touches on it, there's only going to be one of these on there, a 3-system equation like this, other than the matrices one, which is just plug and chug in your calculator. But this one right here is very similar to the one that will be on the test, all right? Very similar. So now when I simplify, what I have is this, 3x minus y. When I add 4 to both sides, that equals 10, right? So this is the equation for number 1 when simplified. Down below, when I kind of distribute that negative there, I'll get plus 4 minus 2x. Put all this stuff out there. Combine together, I get negative 3x minus y, subtract 4 equals 0. All right, so all I did there was just simplify. And again, this right here, we have equation 3 and equation 1 right there. All right, so we just got that set up. Now, as I look at that, one thing we notice is that we could cancel out, just kind of set up that way, the 3x and negative 3x. So we can eliminate that. All right, so that's elimination, right? Rachel, does that make sense? That's elimination, whereas up here, we use substitution when we put in for both. So once I do that, I get negative 2y equals 10. So what would y be equal to? You see that right there? I just combined here and here. When I divide by negative 2.
Oh, sorry.
You're good.
Negative 5.
Perfect. Yeah, so y equals negative 5. And what I could do is actually plug into the top here. So what I could do is say 3x minus negative 5, all I'm doing is substituting in here, equals 10. So once I get this here, I'll get 5. I'll subtract 5 to where I'll get 5 equals 3x, divide by 3, divide by 3, x equals 5/3, okay?
Where do negative 2?
This one right here, that negative 2, all I did was divide to both sides, right? So when I did that, I get y equals negative 5. There.
Where did it come from?
Yeah, let me see. Yeah, so we had this one. This is my first one, right? It's a great question. Yeah, this one's the third one. When I see that 3x and negative 3x can be canceled, we cancel it there, leaving us negative y minus y is negative 2y equals 10. Divide by negative 2 equals, and then it's y equals negative 5. And that's how we found that there. That's a great question. And but that's how we would set that up there. Does that make sense? Yeah, that was it. Yeah, just combine them all the way down. Now, one thing that I noticed is this. Can y'all come back up here for me just for a second? Right here we've got, I think I actually kind of messed this up, I think. Let me make sure. This was -4, right? This was -4?
Yeah.
You see it? I should have subtracted 4 there. Do you see what I'm saying? So like right here, it should be really -8. I had gotten the sign mixed up. If you get a fraction on the test, maybe just go back and check. That's not to say you can't get a fraction, but that's to say that just go back and double check it when you're finally done. So really, what we should have had happen is this is no longer 10, but 10 minus 8 is actually 2. And when I divide, it should be -1. That's my fault completely. So what I'm going to do is, because of that, and again, sorry back at home. Hopefully you checked me on that. If you see it here, again, it should be -4 minus 4, not -4 plus 4. And that was my problem there. So when I substitute -1 back in, I'll have 3 times -1 minus y, or actually, I'm sorry, this should be x. 3x minus y equals 10. Substitute -1 in for y to get 3x minus -1 equals 10. So 3x plus 1 equals 10. This is going to look better because when I subtract 1, 3x equals 9, right? Well, I can divide by 3. So what does x equal? X equals now 3. Okay? Now, once I get x equals 3, I could substitute back in for the top here to get z equals -4 plus 2 times 3. 2 times 3 is 6. -4 plus 6 is 2. So z equals 2 there, where y equals -1 and x equals 3. All right? So again, just another way to kind of go approach that one and do it. One thing is this, as you saw with me, it's very easy to mess up with this. Make sure I kind of do as I say, not as I do type of thing. Show as much work as possible. I know we're trying to rip through problems right now and try to go through as many as we can, but please show work a lot more than what I showed here. Don't skip steps. Make sure you go through. Again, a lot of times it's not necessarily because we don't understand, but because we make a silly error like I did, okay? So just make sure you do that when you go through. You can also plug all 3 of these back in and check to see if it's correct. And I would recommend you do that as well, all right? All right, questions on that one? All right, y'all have another one.
Okay, I don't know, this is probably my last one.
Yeah, you're good.
I was working on number 9,
Yeah, number 9.
and so I tried to solve for x on the bottom,
Okay.
or x on the second equation. And when I did that, I got x equals 5/3 minus 2y. And when I plugged that in, I ended up canceling out all the y's. I plugged it into
Gotcha. So Jalen said that you isolated x, right?
Yeah, I isolated the x in the second one. I plugged my answer and it canceled out the y's in the first one.
Perfect. When I put 1 and 2 circled, that just means first and second. Okay, just so you know. So right here, Jalen said he subtracted 6y, which is fine. You can do that. You can also do elimination. That's fine too. Either one is fine. So now we've got 3x equals 5 minus 6y. All right? Divide by 3, divide by 3, all the way around. We get x equals, anytime, man, x equals 5/3 minus 2y, right? And so what Jalen did is he took this one, substituted in for the top one up here. So now we've got this. We've got 2 times 5/3 minus 2y plus 4y equals 7. All right? Now, Jalen, you're exactly right. Because when we distribute this 2 here, we end up getting 10/3, right? Because 2 times 5, 10/3, minus 4y plus 4y equals 7. Well, once we do that, we get the y's cancel, right? So now we have no variable. Now remember, if we got where 0 equals 0, that means it's infinite solutions, right? Infinite. And we say that that is consistent, right? Because even though it's infinite, it's consistent because there's a solution. The only time it's inconsistent is if we have parallel lines. And that means that if I have something like 0 equals 2, 0 equals 5, where that's not true, right? That's not true.
So this would be inconsistent, right?
Perfect. It would be inconsistent, and there would be how many solutions? No solutions. And you might say, Coach, how can you figure that out? Well, again, if I subtract 10/3 to either side, I'll get 0 equals some number. Well, 0 equal a number is not true, right? So because it's not true, we're going to just say it's not equal, infinite, or no solutions, and it's inconsistent, all right? Great question. That's a good one there.
Can you email this over? Send it on to me?
I will definitely do that, all right? You want to do one last one, y'all?
Sure.
All right.
What do you suggest?
All right, so I'll give you a couple of things, especially for the podcast, some things that we could look over. First thing is this. Let me see if I can pull this up. In fact, this would be good. Just anytime, man. Thank you, Jalen. I appreciate it. One thing that I want to go over with you, just real quick. This problem right here is another word problem that you might want to just take a picture of. I'll show it during class, and we'll do that. But I want to make sure that it's on the podcast as well. Another one that you'll need to do or know how to do. Remember, we used our calculators to know how to find intersection. That's a good one. Also, matrices. Remembering how to do that too. We could look at that again today. But that's also important as well. And then also the fraction one, number 13.
Do number 13.
Thank you, Kenzie. Have a good day.
You too.
Let me do this here. Pull this bad boy up. I think, let me see. Hold up. See that here. Let's see. Let's go here. Awesome. There we go. All right, let's look at the last one, number 13. The reason why I showed number 13 is it's all in the approach. Meaning, if you could approach this in the right way, you'll get it right every time. All right, you'll get it right every single time. So, first thing is no one likes fractions, right? I don't know why people don't, but they just don't. They'd rather work with whole numbers, right? Integers. So what we could do is actually change these into integers by multiplying the top and bottom equation by something that's in common. For instance, on the top one, we can multiply by a value that gets rid of that 5 and 2, which would be like 10, right? So if you multiply the top by 10, you got to do it to all three. What one can we multiply the bottom by, Rachel? What do you think?
Multiply by 4 and make it
Perfect. Yeah, if I multiply the top, I could multiply each by 4. So let's look at the top one, number 1, equation 1. 10 or 5 goes into 10 how many times?
4.
Yeah, 2 and then multiply to get 4.
I'm sorry, I'm thinking about 20.
Oh, you mean, yeah, okay, gotcha. Yep, that's exactly right. So we get 2 here, 2 times 2 is 4, and we're good. What would we get at the top here?
10. And then divide by 275.
Perfect. So we got minus 5y, right? Equals 40. Make sure we get that there. We simplify that on that side, all right? Now on this one, how many, again, 4s can cancel there, right? Leaving us with x, and then these can cancel here. Plus y equals. Perfect. Now think about this with me for a second. We could stop here. What could we do now to be able to simplify?
I don't know.
We could use one of 2 methods, right?
Oh, substitution.
Perfect. Here's a hint. If I see x and y by itself, to me, I'm going to say I'm using elimination every time. Does that make sense? So we can multiply the bottom one by 5. So where it gets 5x plus 5y equals 5 times 28, and we'll go from there. Got me?
Yeah.
And that would be the like how we would approach it there.
Okay.
Does that make sense?
Yeah.
And same holds true with number 12. Y'all at home, make sure on number 12, multiply by 10 at the top, and when you do, you get rid of that decimal there and kind of go forward. All right? All righty. This has been Coach Johnson with Pre-Cal Review. I hope this was helpful for you. We're going to look more at this tomorrow. If you have more questions, come on in either tomorrow morning or I even think Thursday morning from about 8 to 9. I'll have some opportunities to do that as well, all right? Here's Tiger. Tiger coming in live with you. Hey, have a great day. See y'all. Happy studying. Bye.